uses, maybe why it's required in power transmission, electrical power transmission. The transformer is played a major role, right? It's a very important role as well as. So அப்படின்னு பார்த்தோம். But anyone just Google it, right? So டிரான்ஸ்ஃபார்மர் ஃபில்ம் பார்த்துருக்கீங்களா? டிரான்ஸ்ஃபார்மர் ஃபில்ம், ரைட்? ஸோ திடீர்னு கார் ஒரு ட்ரக் இருக்கும், திடீர்னு கார் வந்துட்டு ரோபோட்டா மாறிடும். தென் இட்ஸ் அ ஃபேமஸ் மூவி, ரைட்? ஸோ ஃபேமஸ் சீரீஸ் ஆஃப் டிரான்ஸ்ஃபார்மர்ஸ், இட்ஸ் அப் டு டிரான்ஸ்ஃபார்மர் 4, 5, ரைட்? ஸோ கார் ரன் ஆகிட்டு இருக்கும், திடீர்னு இட்ஸ் நாட் சேஞ்ச் என்டையர், தட் ஃபிசிக்கல் ஸ்ட்ரக்சர் இஸ் கோயிங் டு பி சேஞ்ச் என்டையர் இன்டு ரோபோட்டா மாறிடும், ரைட்? ஸோ லெக்டு ரோபோட். And that leg robot is, again, it's now converted into car actually. So then that film itself, it could have that meaning, right? So transformer, right? So one form of system is now going to be entirely changed into another form of system of Marudo, right? So car is now converted into and that robot Amaru, right? So you could see that entire thing, right? So the same way in power transmission, right? So in thermal power plant, so we are just going to generate power supply. So in Metur thermal, let us consider. So late Metur thermal power plant, we are just considering just as a like a power generation station. So usually it's now in alternative current, right? So alternative we call it as AC power supply. Because of a DC source எங்க இருக்குன்னா நம்மளுடைய solar power plant and battery sources, and those things will be for DC. Directed DC generate பண்ண முடியாது. So you could only have a DC ஓட power source பார்த்தீங்கன்னா battery as well as solar panel. So through that only we can give direct current to appliances. So someone have given an answer actually. So Kavya, yes, we can give direct current to appliances. So for give AC, we use transformers, sir. We cannot give direct current to Kavya. எனக்கு புரியலப்பா, நீங்க just unmute your mic. என்ன சொல்ல வரீங்க?
சார் அப்ளையன்சஸ்க்கு வந்து டைரக்ட் கரண்ட் கொடுக்க முடியாது சார். ஸோ அந்த எங்க ப்ரொடியூஸ் ஆகுதோ அங்க இருந்து கன்வெர்ட் பண்ணி டிரான்ஸ்ஃபார்மர் வச்சு ஸ்ப்ளிட் பண்ணி கொடுக்கறதுக்காக தான் டிரான்ஸ்ஃபார்மர்.
Okay, thank you, Kavya, thank you, right? Thanks for your answer, right? And I'm just going to continue with that. So right, so in Meter thermal plant, we are just going to generate alternative current. So naturally we are just going to generate AC power supply. So DC oda power source enga neenga questions raise pannalam. So DC oda power source pathina solar panel, right? And we will have our chemical battery, right? So we will have alkaline battery, right? Unga watch la irukku, mobile la irukku, those batteries now alkaline battery. And through this we could able to generate a DC power source as well as bio just called biogas, right? So biogas is kind of diesel generate, which we can have a DC. And thermal, we are having, this is now our formal case, right? So it's now AC power supply, right? So inga generate பண்ணிட்டு நம்ம homes can use பண்ணிக்கிறோம். That's our home appliances, right? Domestic purpose or industry. So what we are just now consuming. So around distance பார்த்தீங்கன்னா around 600 kilometer away from generation stations. So anyway, so இங்க இருந்து பவர் சப்ளை இங்க டிரான்ஸ்மிட் பண்ணணும்னா பிகாஸ் ஆஃப் இங்க எனக்கு மேட்டூர்ல தான் will have a water, right? So water resources will be available in there. So that's why I'm just using that, right? So then only I could able to generate AC power supply. So அப்ப இங்க generate பண்ணிட்டு I'm just going to consume somewhere in around about 600 kilometers away from there, right? So definitely electrical energy and just going to travel, right? So with the help of conductors only I'm just going to, because electricity energy travel பண்ணணும்னா that's called transmit பண்ணணும் அப்படின்னா, for example நம்ம ஒரு place இருந்து இன்னொரு place போறோம்னா we need a vehicle, right? So the same way electricity is now going to be transferred from one place to another place. அப்படி in the sense we are just going to give a transport facility, right? That's called electrical conductors, right? So which is going to be used, right? So for transmit of electricity from one place to another place. Okay sir. சார் என்ன சார் இருக்கு இதுல? நீங்க ஜஸ்ட் நீங்க மேட்டூர் தெர்மல் பிளான்ட்ல அங்க ரெண்டு கண்டக்டர் எடுத்து கனெக்ட் பண்ணிட்டு ஃபேஸ் நியூட்ரல், ரைட்? ஸோ ஒன் இஸ் பிளஸ், ஒன் இஸ் மைனஸ். நம்ம டிசியில் பார்த்த மாதிரி பிளஸ் மைனஸ் பார்த்துருப்போம், ரைட்? ஸோ இது இஸ் கால்டு டிசி பவர் சோர்ஸ், பிளஸ் மைனஸ்னு சொல்லுவோம். ஏசியில் பார்த்தீங்கன்னா ஃபேஸ் நியூட்ரல். ஸோ கொஞ்சம் நோட்டேஷன் மாறும், தட் ஃபேஸ் நியூட்ரல், right? So we'll call it as phase neutral. So symbolically they will call it as PN. In a DC source always they will call this minus symbol kamipanga. Here we will have an alternative power supply. They will call it as this sinusoidal symbol. right? So okay sir, நீங்க இதுக்கு எதுக்கு ஒரு நடுவில் ஒரு apparatus தேவைப்படுது? Simply you could able to connect it to conductors from native thermal plant வந்து 600 km line ஒரே ஒரு கண்டக்டர் மட்டும் போட்டுக்கலாமே, nothing won't happen அப்படின்னு நீங்க கேட்கலாம், right? So what will happen actually in the sense, last class we have discussed, right? So we have discussed something about number of appliances in our home, right? So we have discussed around for example 14,000 watts we are using for a single home unit, right? So in the same way, I have started for a small analogy, right? So there's a 0.5 centimeter dia PVC pipe and as well as a 5 centimeter dia PVC pipe. So right, for example, so we have already started. So நான் என்ன பண்ண போறேன், இங்க water pump பண்ண போறேன். So 1 minute water pump பண்ண போறேன். In a dia of 0.5 centimeter dia of pipe ல 1 minute water pump பண்ணா, for example, our understanding purpose I'm just giving around ஒரு 10 liters water தான் pump பண்ண முடியுது, right? So for example, second case, this first case, in second case அதே என்னது, one more time, the same PVC pipe but diode width பார்த்தீங்கன்னா 5 cm, இங்க 0.5 cm, இங்க 5 cm. ஸோ அதே 1 minute நான் வாட்டர் பம்ப் பண்றேன், around 100 liters என்னால பம்ப் பண்ண முடியுது. Why? Because of this dia is very high compared to this pipeline. So let us consider if it is a copper conductor. If a copper conductor, let us assume this is not a PVC pipe right now, this is a copper conductor. Let us assume the thickness of the copper centimeter is around 0.5 centimeters. So per minute I could able to allow a 10 ampere current, for example, right? 10 ampere current because of now water நம்ம flow பண்ண water இருக்கு இல்லையா, the water is now called as electron. Now consider, I'm just going to have analogy, right? So this is called analogy. So I understood that, so we are just going with analogy. So now instead of water, I'm just going to consider my flow of electron. That's it, PVC, I'm just going to consider copper conductor, right? If you want to learn something, so we need to compare with another the same type of process is going in nearby that environment, that's called analogy. So same process and not same process we could able to compare, right? So instead of PVC pipe and water, I'm just going to consider copper conductor as well as flow of electron inside in it, right? Right, and this is called electron, right? So per minute 10 liters போகுதுனா, for example, I'm just giving a 0.5 centimeter copper conductor, it will use around 10 amps for 1 minute, right? So if the dia of the conductor is now 5 centimeter, let us assume now we'll have 100 ampere, right? So if you are just able to increase the dia, right, or area of the conductor or dia of the conductor, you could able to achieve more number of current. So this is what a simple thing, right? So let us assume, right? So in our home, or single home around 14,000 watts, let us assume or 1,000 homes in a city, a town, into 14,000 watts. அப்போ எவ்வளோ வரும்? 14,000 and more 000. So இவ்வளோ watts for a single town. ஸோ ஒரு டவுனுக்கு இவ்வளோ வருது. ஃபார் எக்ஸாம்பிள் ஒன் சிட்டிக்கு அரௌண்ட் ஒன் மோர் ஒரு 5,000 homes, ரைட்? டோட்டல் 5,000 homes. இப்போ 5 வந்துச்சுன்னா 514 ஆர் how much? 200, right? Around 200 வச்சுக்கிட்டுமா? So 50 plus 20, 70, right? 70, எத்தனை சைபர் வரணும்? டோட்டல் சைபர் 70 plus ஒரு 6 சைபர். So this much watts we need to supply. So for a single city, for a single cityக்கு இவ்வளோ கொடுக்க போறோம், right? So ஒரு ஸ்டேட்ல அரௌண்ட் ஒரு 5 டிஸ்ட்ரிக்ட் இருக்கு. ஜஸ்ட் இமேஜின் into 5, அப்போ 35 or cyber. So this much electricity I need to give for a particular district, right? So it's called kilo mega. 350 megawatts I need to give it for a single day, right? So particular city. So okay, so in the calculations எதுக்கு சார் நம்ம போட்டுட்டு இருக்கோம்? You have a question right now, right? So I told you that, so for example, we'll have for small calculation, if you are having, right? So if you are having 230 voltage, right? So generation, right? For example, 230 volt generation, 1000 ampere voltage. For understanding purpose, I'm just giving, right? So 230 volt, 100 ampere. So power generation. So multiply pannunga, just multiply both things. So when it will get a power. So V into I into cos pi. For example, if it's AC power, I'm just going to consider as 1. Now V into I. So V is now 230 into 1000. For understanding purpose, I'm just giving. அப்போ எவ்வளோ வரும்? 23 and then 000. right? So this is what a total power which is going to be generated by this generator made, for example, right? So around 230 kilowatts. 230 kilowatts is now power generation by this generator, right? So now I'm just going to supply around this much electrical appliances, right, in our city. How many generators I needed? For example, I'm just going with it. இந்த மாதிரி ஒரு 10 ஜென்ரேட்டர் தேவைப்படுது. ஸோ 10 ஜென்ரேட்டர் போட்டிங்கன்னா எவ்வளோ வரும்? சட்டையில் 100 generators, right? So 100 generators இருந்ததுன்னா I could able to meet this requirement. Okay, இதெல்லாம் ஓகே. So இதுக்கும் இது எனக்கு என்ன சம்பந்தம்? For example, I told that, so we are just going to transmit this much power is required. So I'm just going to, for example, I'm just going to have this type, right? So I'm just going to have a generation this much current அப்படின்னா I could have one more zero, one more zero, one more zero. So I could able to somewhat, I could able to meet it my energy requirements. Anyway, in the power நான் transmit பண்ண போறேன் with the help of this conductors, right? So with the kind of conductors, right? So in the form of, I'm just going to allow this much flow of current, right? Definitely I need to increase this area of the conductor. Imagine you will have now, you can feel the difficulty, right? So the real difficulty. So I need to allow this much current, 10, for example, 10,000 ampere current I'm just going to supply to my customers, right? So who are the customers? This much power supplies, right? So I need to travel. So this much current is required. So 10,000 ampere na, just imagine. So your conductor diameter, that's called area, that's called dia of that your conductor, it will be like 10 centimeter, sorry, not a 10 centimeter, 10 meter. Imagine 10 meter width na, just imagine எவ்வளோ பெரிய pipeline நம்ம we need to give it. That's called, instead of pipeline, I'm telling that analogy. So 10 meter இருக்கிற copper conductor, right? So it will be huge. So இதனோட width பார்த்தீங்கன்னா around 0.5 centimeter. இதனோட width total, like this is a copper conductor வச்சுக்கலாம், 0.5 centimeter. That's called 0.5 centimeter, right? 50 mm, right? So sorry, 5 mm, right? So 0.5 centimeter, or maybe 7 mm வரும், right? So if it is a 10 meter na, imagine, so in the board oda width pathina around 2.5, that's called 1.5 meter da. So in the board oda width 1.5 meter na, for example 10,000 ampere ku. So for example I need to build a copper conductor width actually 10 meter. அப்படின்னா எவ்வளவு பெரிய கண்டக்டர் இருக்கும்? நீங்க பைப்லைன் பார்த்துருப்பீங்களா, கெயில் ஃபியூவல் பைப்லைன்ஸ், ரைட்? ஸோ அப்போ ஒரு வீட்டோட சைஸு கண்டக்டர் சைஸ் அவ்வளோ பெருசு நம்ம மேனுஃபேக்சர் பண்ணணும். ஐ நீட் டு பி install around 600 kilometer. I need to install that much bigger copper conductor. It's very huge difficult job. Am I correct? You know, ஒரு conductor manufacture பண்றது very difficult, right? So very huge difficult. By what could I say, how that much bigger conductor we need to be manufactured as well as I need to be installed. So இப்போ எங்க இன்ஸ்டால் பண்றது? நிலத்து அதுக்கு போடணும்னா அந்த காப்பர் கண்டக்டருக்கு ஐ நீட் டு கிவ் அ இன்ஸ்டலேஷன். ஸோ இன்ஸ்டலேஷன் கொடுக்கலன்னா ஹவு யூ கட் ஏபிள் டு மேக் அ டிரான்ஸ்போர்டேஷன். ஸோ அவ்வளோ பெரிய காப்பர் கண்டக்டர் நம்ம எர்த்லேயே போட முடியாது. ஸோ வி நீட் டு கோ வித் தட் டவர் லைன்ஸ், ரைட்? ஸோ ஹியூமன் பிக் டவர் லைன்ஸ். ஸோ அப்போ 10 மீட்டர் டயா இருக்கிற காப்பர் கண்டக்டருக்கு, ரைட்ஸ், இமேஜின் how that, what could I say, our weight agule. So 10 kilometers to around 600 kilometers I need to make a street post. In the street post la the copper conductor is now laid actually. So appo lay pandrappo you could see how much strong I need to build this human tower. That's called a tower வந்து எவ்வளவு பெருசு நான் manufacture பண்ணணும் because of this much width of conductor. It's a huge difficult job, right? So இவ்வளவு பெரிய காப்பர் கண்டக்டர் என்னால மேனுஃபேக்சர் பண்ணவும் முடியாது. So where is the materials, right? So காப்பர் உடைய குவான்டிட்டி, எர்த் மெட்டீரியல், எர்த்தில் பார்த்தீங்கன்னா மெட்டீரியல்ஸ் ரொம்ப கம்மியாக தான் இருக்கும், ரைட்? ஹவு ஐம் ஜஸ்ட் கோயிங் டு மேக் தட் மச் பிக்கர் கண்டக்டர், ரைட்? இட்ஸ் வெரி டிஃபிகல்ட், ரைட்? ஸோ ஒன் மோர் திங், ஸோ எனிவே வி ஹவ் மேனுஃபேக்சர், ரைட்? ஸோ அவ்வளோ பெரிய 10 மீட்டர் வித்துக்கிற காப்பர் கண்டக்டர் நம்ம மேனுஃபேக்சர் பண்ணிட்டோம். ஸோ எனிவே ஹியூமன் டவரும் மேனுஃபேக்சர் பண்ணிட்டோம் எனிவே. ஸோ அப்போ இதில் என்ன சார் இஷ்யூ இருக்கு? சார் ஓகே, அவ்வளோ பெரிய காப்பர் கண்டக்டர் நம்ம மேனுஃபேக்சரும் பண்ணிட்டேன். ஸோ பட் இன்னும் ஒரு இஷ்யூ இருக்கு. That's called each and every conductor, that's called copper, each and every conductor it has its own resistance, right? So whenever the electron is going to flow inside that conductor, it will oppose, right? That's called a resistance. In the resistance பார்த்தீங்கன்னா எப்படி கிரியேட் ஆகும்னா, காப்பர் ஆட்டம்குள்ள நியூக்ளியஸ் ஃபோர்ஸ் இருக்கு இல்லையா, தட்ஸ் கால்ட் நியூக்ளியர் ஃபோர்ஸ். இந்த லாஸ்ட் வேலன்ஸ் எலக்ட்ரான் இஸ் நவ் இஸ் பிரேக் பண்ணி தான் எடுக்க போறோம். இந்த நியூக்ளியஸ் இஸ் கோயிங் டு ஹேவ் அ ஃபோர்ஸ் ஆன் மை எவ்ரி எலக்ட்ரான்ஸ். ஸோ இந்த வேலன்ஸ் எலக்ட்ரானுக்கு நீங்க d5/dt கொடுத்து தான் ஜென்ரேட்டர்ல நீங்க கிரியேட் பண்றீங்க, right? So in the force, nuclear force, in the valence electron, there is a force is acting on that. So on the force நீங்க break பண்றதுக்கு தான் we are just going to create a d5/dt. In the force cut பண்றீங்க இல்லையா, that's called its resistance. right? So the force நம்ம break பண்றதுக்கு we are just giving this force. The break பண்ற force is now called resistance, right? So each and every different material it has own resistance value. So for example, this is a common formula, right? So L by A, right? So if the area of that conductor is getting increased, so it could have a lower resistance. If you are just increasing this dia, if you are increasing this dia, you could able to reduce your resistance. Yeah, and the same way, whenever you are just going to increase the length of the conductor around 600 kilometers, we are just going to build it up. So if you are just going to increase that length of the conductor, automatically your resistance is going to be built it up, right? So this is a simple formula, right? So are directly proportional to L by A. This is a practical question. So how we are just going to eliminate these error, right? So அப்ப நான் length increase பண்றேன் 600 kilometersக்கு diaவை increase பண்றேன். So now what will happen actually? So இது இவ்வளவு பெரிய copper conductor we couldn't able to make it. So அப்படியே மேக் பண்ணாலும் 600 kilometersக்கு we couldn't able to transport. So டவர்ல வச்சு transport பண்ண முடியாது. So insulation பண்றது it's very huge difficult job. So what they will do actually, right? So this is the beauty of the transformer concept, right? So that's why I just going to straight away I'm just going to start at different types of transformer and how the energy is transferred. All easy, very easy. But we need to have that exact meaning, right? So what is the need of transformer and why it's required actually? So huge type of copper conductor we couldn't able to manufacture, right? This is a 10 meter with the copper conductor எல்லாம் வந்துட்டு manufacture பண்ண முடியாது, right? So manufacture பண்ணாலும் it's a huge loss. How we could able to lay it out, right? So lay பண்ண முடியாது 600 kilometer, how we can able to manufacture this much copper conductor? It's a big, very huge job, right? So it's a difficult, right? So it's a huge difficult. So actually what they will do actually in the sense, right? So this is a simple concept already we have discussed, right? So see, let us see. So I'm just going to have a copper conductor like this, right? I'm just going to make a copper conductor like this. This is called, already we have discussed, this is called stator coil, already we have discussed. So number of conductor is wounded like this, right? So in the area this is called my area. So in the area I have inserted many number of copper conductors, right? So around like I'm just going to wound like this copper conductor over here. I'm just going to apply AC power supply. Let us see. This is not a DC power source. Hereafter we are just going to only discuss about AC power supply, single phase AC power supply, alternative current power supply. See, okay, இப்போ என்ன சார் நடக்கும்னு பார்க்கலாம். ஸோ இதுக்கு முன்னாடி நம்ம என்ன பண்ணோம்னா we need to understood AC power source, right? So AC power source it will be AC னா என்னன்னு first we need to understood, right? So AC in the sense it's now alternating power supply. This is called time. This is called amplitude. It's called the level of voltage level, right? So it will be look like this. The name itself has the meaning alternative power supply, right? So it will started from zero magnitude and it will end with maximum magnitude and it will come back again zero and again it will go by maximum at a different direction and it will come back zero and it will be keep on moving, right? So this is called amplitude level, voltage amplitude level, and this is called time axis, right? So for example 230 voltage, the maximum amplitude will be 230 per single phase, 230 volt, right? So it'll have this cycle, right? So half cycle and this is one more cycle and this is one more cycle. There is a first half, second half, total is now called one cycle, right? So we'll have one more question, so, right? So we'll have power supply called a standard power supply called 230 volt 50 hertz power supply. So what is meant by 50? So 50 hertz in the sense frequency. So frequency. So this is called one cycle, one half cycle, one more half cycle. This is positive half side, this is negative. The x-axis பாத்தீங்கன்னா மேல இருக்கு, இது கீழ இருக்கு. The same magnitude level. This is called same magnitude but minus 230. So in opposite direction, right? So total ஒரு half இன்னொரு half சேர்ந்துனா ஒரு cycle, right? So number of cycles per seconds, 1 by t, right? T in the sense time, 1 by t. So f is directly proportional to 1 by t. That's called f equal to 1 by t. So within 1 second, how many cycles going to be generated? That's called a frequency. அப்ப இங்க இன்புட்ல பாத்தீங்கன்னா 230 common standard single phase power supply in our India, 230 50 hertz. அப்ப 50 hertz in the sense என்னது? So 1 second la, right? So 1 second la 50 cycles is going to be generated. So this is what a frequency, right? So 1 second, within 1 second around 50 cycles this is going to be generated. That's why it's called 50 hertz. So frequency in the sense 1 by t. So t is defined by time, right? So this is a alternative power supply is now have a positive 230 as well as second line minus 230. The same magnitude will be flipped, right? In the same thing, right? This is the my input power supply will be like this. So positive plus 230 at the same time 230 minus வரும். So இப்போ ஒரு செகண்ட்ல 50 cycles na 1 secondsல, so 1 secondsல 50 cycles is going to be generated. That's called a generator side. அப்படி தான் generate பண்ணிட்டு இருப்பாங்க மீட்டர்ல, right? So now I'm just going to draw only one cycle தான் உங்களுக்கு draw பண்ணிருக்கேன். ஒரே ஒரு cycle தான் draw பண்ணிருக்கேன். So instead of that 50 இந்த பக்கம் வந்துச்சுன்னா 1 by 50, right? So அப்போ 0.02, right? So ஒரு cycle 0.02 secondல it will be going to be generated. So அப்போ ஒரு cycle 0.02 secondல it will be going to be generated, right? So அப்போ 0.01ல half cycle, one more 0.01ல negative half cycle is now going to be generated. So okay, so அப்போ இது plus 230, இது plus 230, இது minus 230, right? So this is called same magnitude is now flipped in the power supply representation, right? We need to apply this voltage into this coil. So this alternative current is now going to apply in this my coil. So what will actually happen, right? So now see, I could say like this, right? So this is called positive, this is called plus. So this is 230, this is minus 230, 230 plus 230 minus, this in opposite direction. So I'm just going to allow into this coil, right? So already we know, right? So AC power line irukum, that's called power nave voltage and current, right? So voltage and current irukum, right? In this AC power supply, right? So current also in this same direction, right? This is called current waveform as well as voltage இதே மாதிரி தான் இருக்கும். In DC ல பார்த்தீங்கன்னா it will be now simply called as straight line. So நம்ம பார்த்துருப்போம் ஜென்ரேட் பண்றப்ப எனக்கு எப்படி கிடைச்சிருக்கும், that DC generator ல it's now look like this, right? So we already just cumulated, right? So cumulative பண்ணிருப்போம். The exact power supply will be like this. So ultimately பார்த்தீங்கன்னா it should be look like straight line. That's why it's called a DC source, right? So it's not exactly straight line இருக்காது. நீங்க shear யூஸ் பண்ணி பார்த்தீங்கன்னா the AC the DC power will be look like this. Somewhat it's getting oscillated. But anyway, we're just having a straight line. That's why it's a DC power. But AC power is not up to this, right? So AC power பார்த்தீங்கன்னா it should be look like this. It will be alternative. So இப்போ என்ன பண்ண போறேன், இந்த power supply I'm just going to allow into this circuit. இப்போ என்ன நடக்கும் நினைக்கிறீங்க anyone? So now this is a closed path, closed conductor. I'm just going to allow, definitely current is now flowing into this circuit. So this is made up of coil. அப்போ என்ன ஆகும், there is a current is now flowing, current is now flowing is in this direction, now in this direction. So current is now flowing and current is now flowing in this direction and it's going, right? So current is now flowing like this, right? In this manner. So what will happen, we already know whenever the current is flowing in any closed path of maybe any conductor, definitely there is a magnetic flux lines will be going to introduce, right? Here many number of conductors are wounded here, but definitely now many number of flux lines is going to be generated, right? Nalla watch panninga, this is called my 5 flux lines is going to be generated because of current is now flowing, right? So let us see the current order representation pathina. I'm having a AC that's called alternative current. Why it's in the form of in this nature? Because my applied voltage is also my in this nature, my applied voltage also in this alternative nature, my applied voltage also in alternative nature. So flow of current is also alternative nature. So up inducer flux lines is also in alternative nature. So I'm just going to draw in a single diagram, right? So if input voltage will be like this is called voltage waveform. The same way current is now in the same waveform. This is my current waveform. Due to this current flow in this network, there is a flux is going to be introduced. That's called electromagnetic induction, Faraday's law. So there is a flux line is going to be introduced. So nature of this current is like this. This definitely the induced flux lines also the same structure, right? So if the current is maximum, definitely V is maximum, definitely I is maximum. If the current is maximum, the flux line is also maximum. So I already know. So if V is directly proportional to I, right? So this is called simple Ohm's law. When I am just going to apply more voltage, there is a flow of reluctance which will be very high. That's called V directly proportional to I. So if the current is now maximum, so I is also directly proportional to pi, induced flux lines. V is directly proportional to I is directly proportional to pi, right? So நல்லா வாட்ச் பண்ணா தெரியும். I told that. So 1 secondல 1 secondல sorry 0.02 secondல one cycle is now generated. This is called 50 hertz power supply. So this is what 0.02 second. So இந்த ஒரு half 0.01 secondல create ஆயிருக்கும். இது 0.01 secondல create ஆயிருக்கும், right? So this is what one cycle, right? So it's now generated from the power supply. The same way நல்லா வாட்ச் பண்ணி பாருங்க, அடுத்த 0.03 செகண்ட்ல என்னவா இருக்கும், இது பிளஸ் வந்திருக்கும், அப்புறம் மைனஸ் வந்திருக்கும், இது கரண்ட் அதே மாதிரி வந்திருக்கும், பிளஸ் அதே மாதிரி வந்திருக்கும். இப்போ என்ன ஆகுது, ஃப்ளக்ஸ் லைன்ஸ் இஸ் நவ் சேஞ்சிங் வித் ரெஸ்பெக்ட் டு டைம், ரைட்? ஸோ பிளஸ் மைனஸ் பிளஸ் மைனஸ் பிளஸ் மைனஸ் சேஞ்ச் ஆகிட்டே இருக்கு, ரைட்? ஸோ நவ் வில் ஹாவ் அ dφ by dt, நேச்சராகவே dφ by dt is now happening. Just got idea. I'm just going to stop it somewhere here, then only you could able to have idea, right? So I'm just going to stop somewhere here. So இது ஒரு டவுட் இருக்குங்களா? Because by giving input power supply nature, so now dφ by dt is now going to happen. Any doubt in this? Why is now dφ by dt is happening? Because my input power itself, it has a changing with respect to time. So that's why voltage also changing with respect to time. So due to that voltage wave, right? So we could also have a current is also will be in the form of the same, how the voltage is going to change, the same way current is also the same waveform. And due to that nature of current in this the same structure, so definitely the flux lines also will be in the same thing. Idella doubt irukungla? Any doubt in this? Any doubt up to this? Anyone? Just anyone just say whether you have a doubt or not. Idella doubt irukungla? Physically I think it will be very easy for me, but so it's somewhat difficult. It's understood agudungla? Any doubt in this up to this? Because of AC power we need to be discussed, right? So we'll have a separate class for AC power. Why it's called in a mari waveform eppadi sa generator we'll discuss later, while AC generator varappa we'll discuss in a detailed manner, right? So anyway, maybe next class I'm just going to start about this AC power. So then only you'll have no doubt in this, right? So anyway, let us now see AC voltage. It will be like this. So நமக்கு தெரியும் இல்லையா, பவர்னாவே என்ன இருக்கும், பவர்னாவே என்ன இருக்கும்? ஸோ எலக்ட்ரிக்கல் பவர்ல voltage multiplied by current, this is called power. If it is a AC power, na, there is a cos phi, that's called a power factor, it will be coming. So power factor, let us assume now it's 1. So power factor na onnu illa, this is called a voltage waveform, and this is a current waveform. So if it is both are same in phase, there is a cos pi is now is equal to 1. So we'll discuss in detail with while coming with AC generator will coming, that on the topic will detailed படிப்போம். Now with the transformer, right? I'm just going to apply this alternative voltage over here. The structures will be like this. So definitely voltage அந்த மாதிரி இருக்குன்னா current அதே மாதிரி தான் develop ஆகும், right? Because of in the place V is 0, right? So in the point பார்த்தீங்கன்னா V is 0, same way current is also 0. Now see, keep on my V is getting increased about maximum positive. Definitely current is also maximum in positive direction. If the current, the voltage is now it's getting decreased, definitely the current is also getting decreased. If the current is now 0, voltage is 0, current is also 0. The voltage is now increasing in opposite direction, definitely the current is also in inducing opposite direction. That's why I told that. So it's called simple Ohm's law, V directly proportional to I. The same way the current, this type of current is now flowing in this circuit, in this coil. Definitely the flux lines also, the current is now 0, flux lines is 0. If the current is now increasing, definitely the flux is going to be increased. If the maximum current is allowed, so maximum flux line is going to be generated. If the current is now decreasing, flux line is also decreasing. If the current is in opposite direction, the flux is also generated in opposite direction. So this is what the same structure which is now following, right? So definitely இப்போ பாத்தீங்கன்னா இது 0.01 செகண்ட் லெவல் நடந்திருக்கு, இது 0.101 செகண்ட், அடுத்த 0.01ல பாசிட்டிவ் வரும், அடுத்த 0.1 நெகட்டிவ் போயிடும். So itself it has a meaning. So plus 5 minus 5 plus 5, that's called dφ by dt is now happening, right? So இதுல doubt இல்ல நினைக்கிறேன், I guess, right? Say yes or no. We are just going to have one more setup over here. இதெல்லாம் doubt இருக்குங்களா? Any doubt in this up to this? So okay, யாரும் பேச மாட்டேங்கிறீங்க. No sir, Kirtana, right? Thank you, Kirtana. And I'm just going to see நான் input power supply கொடுத்திருக்கேன், that's called V causes I is now flowing, I causes this flux line is now going. So அப்ப என்ன ஆகும், if the current is flowing maximum, so if I'm just going to increase more current, if I'm just going to apply more voltage, there should be more current. So more current will give you more flux lines. So I'm just going to draw more flux lines. More flux lines. I'm just going to draw more flux lines because of more current is now flowing. More current is now flowing, right? And now why I'm just going to place. Let's see. I'm just going to place one more coil into this field. One more coil I'm just going to place into this field. This is called field area. This because of this current is now flowing, so magnetic flux lines is now producing. This is called magnetic flux lines, right? So mmf. So that's called magnetic flux lines, magnetic flux densities, right? I'm just going to place one more coil. So one more coil, like this copper conductor மாதிரி இப்போ coil பண்ணல அதே மாதிரி one more coil I'm just going to place over here. So இப்போ என்ன பண்ண போறேன், I'm just going to place one light, right? I'm just going to place one light. So இப்போ என்ன ஆகும்னு நினைக்கிறீங்க, இந்த லைட் எரியுமா எரியாதா? Anyone up to this? இப்போ என்ன பண்ணிருக்கேன், first setupல I'm just going to connect a AC voltage source. Now due to that voltage in AC nature, alternative voltage nature, there is a voltage will be like this, current will be like this. Current, if the current will be like this, induced fluxes will be in alternative nature, right? I'm just going to increase more voltage, definitely more current will flow, more flux lines also getting introduced. But the introducer of flux lines is now changing with respect to time, plus minus போயிட்டே இருக்கு, right? அப்புறம் என்ன பண்றேன், second step, I'm just going to place one more copper conductor like coil, this one, and both end I'm just going to connect one small light, right? Small light I'm just going to connect it. இப்போ என்ன ஆகும்னு நினைக்கிறீங்க? Anyone? Just unmute your mic please, everyone, just anyone. இப்போ என்ன நடக்கும்னு நினைக்கிறீங்க? I'm just going to make one more coil near to that field, right? Now I'm just going to connect a light. இப்போ என்ன ஆகும்னு நினைக்கிறீங்க? Anyone? இது புரிஞ்சதுன்னா டிரான்ஸ்ஃபார்மர் ஈஸி, அவ்வளவுதான் டிரான்ஸ்ஃபார்மர். இட் ஃபினிஷ் 90% டிரான்ஸ்ஃபார்மர் கான்செப்ட் இஸ் நவ ஓவர். இப்போ என்ன நடக்கும், அந்த லைட் என்ன நடக்கும்? ஸோ எல்லாரும் ஸ்பீக்கர் ஆஃப் பண்ணிட்டீங்களா, நான் மட்டும் தான் தனியாக பேசிட்டு இருக்கேனா இல்லை நீங்களும் இருக்கீங்களா? anyone just unmute your mic, give me some hint actually. So நல்லா வாட்ச் பண்ணி பாருங்க, it's very easy. This is also made up of copper conductor, right? So this is also made up of copper conductor. So now d phi by dt is now occurring because of change in current and change in voltage, change in flux lines, right? So d phi by dt is now every instant of second is now changing. நல்லா வாட்ச் பண்ணீங்கன்னா தெரியும். Now there is a closed path conductor with there is a light. So this is also coil. So now in the coil link our flux lines is now changing with respect to time, right? So d phi by dt is now occurring into this coil. அப்ப என்னவாகும், again copper conductor, copper nucleus, copper atom, d phi by d is now disturbing this last valence electron. அப்ப electron is now valence electron is light will glow. Thank you Kirtana. Yes, யாரோ ஒருத்தராவது பேசிட்டீங்களே, right? So thank you Kirtana, right? So right now
Light slowly
yes,
start to glow, sir.
yes, light will glowing. Thank you pa, thank you a lot. இவ்வளவு நேரம் ஆயிடுச்சா? Thanks a lot, right? So it will happen. So I'm just going to explain it, right? So now d phi by dt is now linking with this copper coil. So again we need to go with that last topic, right? So we have discussed copper this copper conductor is made up of copper atom, and valence electron is now disturbed by this d phi by dt. Now this valence electron is now act as a free electron. This electron will be moving. So one electron illa n number of electron will be released from this coil, right? So it's now going, it's going. If the light is now connected, light will glow. If the fan is connected, fan is now going to be rotate and it will be glowing. So this is what a transformer, right? So this is what a transformer. So நல்லா வாட்ச் பண்ணீங்கன்னா தெரியும், here in first domain the electrical energy is coming towards this thing, and from this coil electricity energy is now converted into magnetic domain. Again that magnetic domain is now converted into back to electricity. That's all. So I'm just going to rough it. இது photo எடுத்துக்கோங்க, anyone just have a snap. So ரொம்ப கிரிக்கி இருக்கு, பட் எனிவே லிசன் பண்ணிருந்தீங்கன்னா மறுபடியும் நீங்க இந்த போட்டோ ரீகால் பண்றப்ப இட் வில் பி வெரி ஈஸியஸ்ட். எனிவே ரெக்கார்டிங், வீடியோ ரெக்கார்டிங் இருக்கு, நோ இஷ்யூஸ் அட் ஆல். So anyone just took a photo. I'm just going to repeat and as well as I'm just going to draw in a neat manner, right? So I'm just going to draw 1 second. நிறைய இன்ட்ரோடக்ஷன் கிளாஸ் நிறைய கிரிக்கெட் இல்லையா, so I'm just going to read it one more time. Now we'll go with that engineering diagrams. It will be very easy, right? So I'm just going to draw like this. Right, I'm just going to apply voltage here. Input voltage, that's called AC. I'm just going to draw. Right, up input voltage is now applied voltage, that's called E suffix supply voltage E suffix S. Current is now flowing in this circuit is now maybe primary. We will call it as primary, right? So we'll call it as this is called primary circuit. So the current is now flowing in the circuit is primary current, and there is a flux line is going to be generated because of primary current is now flowing, right? Primary voltage is now generated. That's called the primary flux lines. That's called 5P. That's called 5P. Primary flux lines is also changing with respect to time because of AC nature. So now I'm just going to connect a small light. Now it will start to glow because of change in flux lines with respect to happen here also. So I'm just going to call it as, right? So I'm just going to connect on voltmeter. So for measuring how much voltage is going to be generated in this second circuit, this is called E suffix S, second circuit. So in the light glow, there is a current is now flowing. That's called secondary current. That's called EIS, right? So is there any doubt in this actually? So inga pathina theriyum here one box, right? So this is my primary. This is called coil, primary coil or primary winding. This is called my secondary winding, right? I'm just giving electrical input. Nalla watch panni parunga, electrical input. In primary winding I'm just giving electrical input. Now secondary winding light is glowing, so now secondary also electrical because நடுவில் பாருங்க எந்த கான்டாக்டுமே இல்லை, எந்த காப்பர் கண்டக்டர் எதுவுமே இல்லை, பட் எலக்ட்ரிசிட்டி இஸ் நவ் கமிங் ஃப்ரம் திஸ் செகண்ட் காயில், electricity output, right? So just see, there is no conductor in between, direct conductor எதுவுமே இல்லை, பட் நடுவில் ஏதோ something is happening, that's called magnetism, right? So that's called magnetism. அப்போ பார்த்தீங்கன்னா டிரான்ஸ்ஃபார்மருக்கு என்ன நடக்குது? I am just going to give a electrical input and it's now converted into magnetism. Again, this magnetism is now converted into electricity. That's why in initial stage, very first class, I told that electricity and magnetism are two sides of a single coin. So in the side pathina electricity and the magnetism. So we couldn't able to segregate this in individually, right? So this is called two things, right? So this is called primary winding. This is called primary winding. This is called secondary winding. And this is called my flux lines, right? Anyway, I'm just going to somewhat rearrange this one because of this flux lines is now generating in this area that's called air medium, right? So this is called air medium. So air medium, I'm just going to working, right? So air medium, there is a big losses will be happening. So because of flux lines is now moving all the way 360 degree, so anyway இந்த பக்கம் வேஸ்டா தான் போகும். பட் எனக்கு எலக்ட்ரிசிட்டி எங்க எனக்கு டிராவல் பண்ணணும், டிரான்ஸ்ஃபார்ம் பண்ணணும். I'm just going to transfer this electrical energy which I'm just going to feed it to this coil is now automatically transformed into this coil, right? So I need to get it the same electricity which we are just going to pass it here. It will be completely, it needs to be traveled and it's going to be transferred to this side. But anyway, in the air medium, we are just going to travel in the sense there is a huge losses is going to occur in the form of magnetic flux lines. So for avoiding this purpose, we are just going to introduce one more medium to travel this all flux lines. It needs to be traveled through that medium. It needs to be traveled over here. Then only the electricity is now we are just transmitting here. It will be traveled toward this scale. So for that purpose, anyone just took a photo. I'm just going to little fast introduction. That's why I'm just going to little bit move forward. Anyone just make it fast. Right, I'm just going to draw one more thing. Yes, I'm just going to give you that medium to travel those flux lines, right? So for that purpose, what I'm just going to do, right? So I'm just going to have a steel a plate or iron plate, both we could have that plate, right? So I'm just going to place a steel stamping plate, or maybe you could have a iron plates, irons, right? So I'm just going to wound like this. Now I'm just going to wind a coil on steel plate, but instead of directly I'm just going to plate, right? I'm just going to have a paper, right? So there is a insulation paper or maybe plastic paper. We are just going to place on this steel plate, so steel, right, steel. I'm just going to winding this copper conductor, right? So before into there's a paper will be there. There is no direct physical contact. That's direct electrical contact. It will not be there. So there is a direct mechanical contact, but there is no electrical contact between this steel as well as this copper conductor. There is an insulation will be happening be into this, right? So ஒரு பேப்பர் மாதிரி வச்சிருவேன், பேப்பர் வச்சுட்டு I'm just going to wind it, right? There is no direct electrical conductivity between this steel as well as this copper conductor. I'm just going to have a small paper in this, and then I'm just going to place it. The same way, my secondary side, I'm just going to same thing. I'm just going to draw, but before into that, I'm just going to make a paper, and I'm just going to wind it. That's called insulation purpose, right? So I'm just going to light ingo light connect பண்ண போறேன், right? So now I'm just going to allow flow of current in primary side. I'm just going to apply single phase AC voltage, AC source. I'm just going to give 50 Hz power supply. Now the E, it's called primary, E suffix P is now voltage is applied. Current is flowing in this circuit is now primary current, right? So this is called iron piece, that's called our steel. It's purely good conductive material as well as, right? So pure little bit conductive material over same rates, right? So now I'm just going to apply flow of current in the sense there is a flux line is going to be generated around this coil, right? So this is a magnetic property material, right? So definitely a flux line is now going to be generated like this, right? So the flux line is going to be generated. This flux lines is now attached by this entire steel plates. Now the entire steel plate is now act as an electromagnet. So the entire steel plate is now act as a magnet. So the entire plate is now act as an electromagnet. So this flux line is now attached with this coil is now traveled and all the way traveled from this entire steel plates. அப்ப secondary currentல என்ன பண்ணிருக்கேன், I'm just having a same conductor. அப்ப definitely now the flux losses, right? So the air medium, instead of air medium, here we'll have a that restriction. Air medium போகாது. Entire flux is going to be generated in this thing is now linked with this entire steel plates, and it will be now traveled, and the secondary current is now flowing, light is also flowing. The secondary voltage is now E suffix yes, secondary voltage. So this is a simple thing. Now this is exactly called transformer, right? So electrical energy is now transformed into magnetism domain, and then magnetism domain is now again converted into electricity domain. That's why it's called transformer. அந்த ஃபில்ம்லயே அதான் பார்த்திருப்பீங்க, லைக் ஒரு கார் மாதிரி இருக்கும், அந்த அது ஃபில்ம்ல பாத்தீங்கன்னா தெரியும், ரைட்? Now it's entire thing is now converted into robot மாறும். Again the robot is now converted into car, right? So this is called transformation. That's why அதுக்கு பேரே பண்ண ஃபில்முக்கு பேரே transformer வச்சிருப்பாங்க. The same way the name why it came from that movie, this is the meaning. So we are giving electrical power supply. So electrical power supply is now converted into magnetomotive, that's called magnetic energy. Again magnetic energy is now converted into electricity. So electricity energy கிடைச்சிருச்சு, but there is a transformation. It's like magnetism domain போயிட்டு மாறும். சரி, ஓகே சார், இதனால பண்ண என்ன சார் ஹெல்ப், என்ன சார் யூஸ், ரைட்? ஸோ லாஸ்ட் கிளாஸ் we have discussed around 10 meter dia conductor, right? So 10 meter dia conductor we couldn't able to do that. ஸோ நல்லா வாட்ச் பண்ணி தெரியும், 10 meter conductor நம்ம என்ன மேனுஃபேக்சர் பண்ணிட்டு ஒரு 600 kilometer travel பண்ணா it will be very huge job, huge difficult job, right? So we couldn't able to do that, right? So அப்ப இது என்ன சார் ஹெல்ப் பண்ணும், இந்த மாதிரி பண்ண என்ன சார் ஹெல்ப் பண்ணும்? எனி ஆன்சர், யாராவது நீங்க ஆன்சர் பண்ணலாம். So I'm just going to stop it somewhat here, right? So instead of creating 10 meter dia conductor, it will be huge difficult job. So while manufacturing that copper conductor, right? So and the same way we couldn't able to lay out those conductors with the help of and 600 kilometers away from the stations, right? It will be very huge difficult job, right? So but we are having this setup. So in the மாதிரி setup நம்ம பச்சா நமக்கு என்ன யூஸ் actually, right? Anyone? நீங்க தான் ரிலேட் பண்ணணும். So then only it will be I'm happy about that if I just related it. இந்த மாதிரி செட்டப் நான் கொடுத்து பண்ணா what actually it's going to be helpful while transmitting the electrical power supply. டைரக்டா எலக்ட்ரிக்கல் சப்ளை நான் மேட்டூர் தெர்மல் ஸ்டேஷன்ல இருந்து நான் டொமஸ்டிக் பர்பஸ்க்காக இண்டஸ்ட்ரிக்கு கொடுக்காம ஐ எம் ஜஸ்ட் யூசிங் திஸ் செட்டப். இந்த செட்டப் நேம் தான் we are call it as transformer. Right now we are calling the name, the setup name called, we call it as transformer. பட் என்னோட கான்செப்ட் நம்ம அண்டர்ஸ்டுட் பண்ணிட்டோம். இங்க ஜெனரேஷன் ஸ்டேஜ்ல பவர் சப்ளை கொடுக்குற is now converted into mechanical, that's called magnetomotive force, that's called magnetism domain. Again that domain is now converted into electricity. So in the transformation called the transformer. But answer படிச்சாச்சு, but question என்ன? Just imagine, we are just going in opposite direction. So then only the concept it should be in a உங்க கான்சியஸ் மைண்ட்லயே இட் கோயிங் டு அட்டாச், ரைட்? அதுக்காக ஐம் ஜஸ்ட் ஆஸ்கிங் திஸ் டைப், ரைட்? ஸோ என்ன நடக்கும்னு நினைக்கிறீங்க? இதனால என்ன நமக்கு பெனிஃபிட் இருக்கும்? எனிவன்? ஒரு 10 மினிட்ஸ் இருக்கு இந்த கிளாஸ்ல, ஸோ நீங்க தான் ஆன்சர் சொல்லணும், ரைட்? உங்களுக்கு ஆன்சர் தெரியுங்கிறது எனக்கு தெரியும், பட் யூ couldn't able to that give that answer. உங்களுக்கு ஆன்சர் தெரியும், ஐ நோ, ரைட்? பட் யூ ஆர் நாட் கிவிங். தட்ஸ் மை கொஸ்டின். நான் சொன்ன பிறகு அது இதுதான் ஆன்சர் அப்படின்னு நீங்க கேட்கக்கூடாது. ஆன்சர் இஸ் வெரி ஈஸி. ஆல்ரெடி யூ நோ, ஆல்ரெடி வி ஹவ் டிஸ்கஸ்ட், ஆல்ரெடி வி நோ, ரைட்? என்ன நடக்கும்னு நினைக்கிறீங்க? Anyone? Just think of it. For example, I'm just giving a small example. Today itself we have discussed around 250 megawatts, right? 350 megawatts energy we need to be generated. So for example, inga 350 megawatts consumer, right? So evlo energy we need to be transferred to that society. But this generation station, right? Generation station, அப்ப 350 megawatts generating electricity travel பண்ணனும்னா I need to go with it. For example, 10 meter dia of conductor is required. So already conductor we couldn't able to manufacture as well as installation பண்ண முடியாது. So it's a huge job. அப்ப என்ன பண்ணலாம் அப்படின்னா, just imagine. So for example, I'm just giving a small example. So 230 voltage, right? So 50 ampere. So maximum voltage எவ்வளவு? 230. Generation station 230, 50 ampere, right? So I'm just going to multiply both things. So 230 total power 230, 50 ampere. Multiply பண்ணுங்க, 230 into 50 எவ்வளவு வரும்? 5 now right? So 115000. So this much watts, right? So 11,500 watts is now transferred to this generation station to 11,500 watts. It needs to be traveled from over 600 kilometer. We need to be traveled, right? And we're just going to supply it, right? If enna panna porona, we'll have a small option. So for example, 50 ampere I'm just going to generate, right? So instead of generating 50 ampere, I'm just using a 1 centimeter dia of conductor for required for a flow of 50 ampere. For understanding purpose, I'm just going to give you later. So how we are just going to choose this dia of this conductor? There is an American wire gauge meter that's called AWG, American wire gauge things is now required. So to measure the thickness of that conductor, right? So for example, I'm just telling, so 50 ampere current is now generating in this generation station. It needs to be traveled around 600 kilometer, and I'm just going to apply it to my domestic appliances, right? So for that purpose, I'm just giving an example. 50 ampere current for required 1 centimeter dia of conductor, right? So 1 centimeter copper conductor நான் manufacture பண்ணனும்னா around 600 kilometer length I need to manufacturing about 1 centimeter dia. For example, the same 11,500 watts is required to travel 600 kilometers, right? நான் இப்ப என்ன பண்ண போறேன்னு பாருங்க. I'm just going to decrease this half. So 230 decrease பண்ண increase பண்ண எவ்வளவு வரும்? So 230 I'm just going to double it, right? So I'm just going to double into 2 terms. So அப்ப I'm just going to multiply this 2 and divide by this 2, right? Imagine. So I'm just going to multiply into 2. அப்ப என்ன வரும்? 460 voltage. 460 voltage. I'm just going to divide into 2. அப்ப 25 ampere. So if the multiply பண்ணீங்கன்னா அதே ஆன்சர் தான் வரும், right? So multiply பண்ணா, so voltage multiply பண்றேன், current divide பண்றேன், right? I could have the same energy, that's called same electrical energy, that's called watts, is now traveled. But எனக்கு என்ன ஒரு advantage na, if I'm just going to reducing this amps rate by 2, அப்ப என்ன ஆகும்? 25 ampere is நான் கொடுக்குறேன் அப்படின்னா conductor thickness என்ன ஆகும்? 0.5 centimeter you could able to reduce. அப்ப manufacturing of the copper conductor is now getting reduced. For example, I'm just going to multiply by 4. I'm just divided by 4, right? I'm just going to multiply by 4, but divided by 4 எவ்வளவு வரும்? 25 50 divided by 4 கொடுத்தா என்ன வரும்? Around 12 ampere வரும். 12. அப்ப copper conductor thickness we could able to reduce, right? So but power என்னவோ அதே தான், voltage மட்டும் increase பண்றேன், current decrease பண்றேன். அப்ப எனக்கு 0.25 centimeter, that's called very minimum thin conductor, right? So I could able to reduce the copper conductor thickness. By reducing this copper conductor thickness, we could able to reduce copper cost. ஏன்னா 600 kilometer I need to lay out that copper conductors. அப்ப dia அதிகமாக I need to manufacturing that much copper conductor, because 1 kg of copper conductor around 3000 rupee or nowadays 3000 to 4000 rupee, or 1 kg of copper conductor, it will be now 3000 to 3000 to 4000 rupee, it will be coming under. Up imagine 600 kilometer, if you are just having one die abina, what is the price, right? It will be very very huge cost. Just assume 10 meter of copper conductor, it will be unimaginable amount. We require unimaginable amount, unimaginable copper conductor is required. So for that purpose, we can have an option, voltage we just going to increase, current we are just going to reduce. So by doing this, we could able to reduce your copper conductor's thickness. So in the same way, you could able to travel. இங்க பாத்தீங்கன்னா நான் மல்டிப்ளை பண்ணி கொடுத்துருக்கேன். ஸோ இன்ட்டு 4 அப்ப கரண்ட் கம்மியா இருக்கு, வோல்டேஜ் அதிகமா இருக்கு. எனவே பவர் இஸ் நவ் சேம். அப்ப இங்க என்ன பவர் ஜென்ரேட் பண்றோம் அதே பவர் தான் இங்க டிரான்ஸ்மிட் ஆகுது. பட் in the form of I'm just going to change that voltage as well as step down that current. Just imagine got my word. I'm just going to step up this voltage around 460 voltage. I'm just going to step it up. I'm just going to step down this voltage and step up the voltage, step down the current. In secondary side, I'm just going to step down the voltage, step down the current, step up the current. This called step up transformer, step up purpose, and second step down purpose. So anyway, power, it will be same power than transmit out, right? So we'll discuss by tomorrow classes in detail. So how the transformer is going to be step up, how the I think 5 more minutes will be there. I'm just going to give you exactly, right? So 5 minutes for more than enough. How it's going to be step up the voltage, how we are just going to step down voltage. Nalla watch panna theriyum, the same power than generation station ku receiving station ku same electrical power is now going, but there is a quantity is changing, voltage quantity is changing, current quantity is changing. How it could be able to change, right? For example, I'm just going to draw this steel structures. This is called my steel structure, right? So idhukku mela I'm just going to make a conduct. Nalla watch panni parunga. Now I am just having a number of winding, so around 10 winding, 10 cycles, right? So 10 n, I am just giving 10 cycles, so 10 n is now number of turns. So here I am just going to only 5 turns, so n is now 5 turns, right? So maybe I'm just going to wind 20 turns, so I'm just going to wound 20 turns, 20 turns, so n is now 20 turns. In this case, number of n pathina inga 10 primary side, so I'm just going to apply voltage, make it fast up paniren, and this is lamp, right? So this is one more voltmeter and parallelly connected, right? So now number of turns in my primary side, that's called EP, is now 10, EP in secondary side around 20. So number of 20, number of 10. So now what will happen actually? So number of turns, that's called electromagnetic induction law, is now induced voltage, that's called is equal to induced voltage. Already we have discussed in DC generator. So pi is changing with respect to time, number of turns. So n is now number of conductors, right? Number of turns is now is directly proportional to d phi by dt. So now you could see this primary side la, in secondary side la, number of turns it will be very high, that's called secondary side. The same, the primary np, this is called secondary ns d phi by dt. The same formula will be occurred. This is called electromagnetic Faraday's law of induction. Whenever the current is flowing inside the coil, the resistor flux is now going to be introduced. It's called p. So the எவ்வளவு இருக்குன்னா voltage induced or voltage, that's called induced voltage, is now multiplied by np into d phi dt, right? See, is both are now connected in a single loop, right? I'm just going to equal to these two things, right? So ep is equal to es is equal to எப்படி இருக்கும் np d phi by dt is equal to ns d phi by dt. So this d phi by dt is common, so it now gets cancels each other. அப்ப எப்படி இருக்கும்? So ep is equal to es is equal to எப்படி இருக்கும்? np is equal to ns. So you could have equation, so ep by np, es by ns, right? You can have this small equations, right? So secondary voltage, that's called secondary voltage, எவ்வளவு இருக்கு அப்படின்னு பாத்தீங்கன்னா, so es ns இந்த பக்கம் வந்துரும், so ns into ep by np. So es is denotes that secondary voltage, right? So நல்லா வாட்ச் பண்ணீங்கன்னா தெரியும், இங்க number of turns 10 தான் இருக்கு, இங்க number of turns அதிகமா இருக்கு. அப்ப என்ன ஆகும்? ஃபார் எக்ஸாம்பிள் இங்க 230 voltage கொடுக்குறேன்னா என் செகண்ட் சைடு எவ்வளவு வோல்டேஜ் இருக்கும்? இன்டு 2. ஸோ நம்பர் ஆஃப் வைண்டிங்ஸ் நவ் மல்டிபிள் பை 2. அப்போ எனக்கு செகண்ட் சைடு எவ்வளவு வோல்டேஜ் கிடைக்கும்? 460 voltage கிடைக்கும். திஸ் இஸ் கால்ட் ஸ்டெப் அப் வோல்டேஜ், ஸ்டெப் அப் டிரான்ஸ்ஃபார்மர். இங்க பாத்தீங்கன்னா நம்பர் ஆஃப் டர்ன்ஸ் தான் இருக்கு, நம்பர் ஆஃப் டர்ன்ஸ் 20 இருக்கு. யூ கேன் ஹேவ் தி ஈக்குவேஷன், யூ கேன் ஹேவ் தி திங். ஸோ இஃப் ஐம் ஜஸ்ட் கோயிங் டு For example, இங்க 20 turns இருக்கு, இங்க 10 turns தான் இருக்கு. அப்ப என்னவாகும்? 230 voltage is now divided by 2 ஆயிடும். அப்ப எனக்கு வந்துட்டு எவ்வளவு இருக்கும்? 125 தான் இருக்கும். Yes, 115 voltage இருக்கும். This is called step down transformer. So we'll discuss in detail by forthcoming classes, right? So I think we reached 3 o'clock. So because triply na இன்னும் கொஞ்சம் in detail போகலாம், but உங்களுக்கு இந்த in detail it's not recorded, I guess. But anyway, I have taught many things, right? So we'll discuss with that continuation next class. We'll discuss in somewhat in detail with that equation. Again, we're just going to recall this equation, no issues. But this is way of step down voltage, step up voltage. With the help of number of turns, we could able to increase the flux lines. Because of number of conductors அதிகமா இருந்துச்சுன்னா induced flux lines is going to be high. Number of turns கம்மியா இருந்துச்சுன்னா the flux induced flux lines will be very low. So this is a simple concept. Just understood that. So if the number of turns, if you're just increasing, it shows that ultimately you are increasing the area of that conductor. If you are just going to wound more number of turns, right? More number of turns, it shows that more number of length of conductor you are doing. அப்ப என்ன ஆகும்? More number of flux lines is going to be generated. So அப்ப என்ன ஆகும்? Minimum voltage கொடுத்தா கூட அது maximum voltage boost ஆகும். If you are just going to secondary minimum turns இருந்துச்சுன்னா அப்ப minimum flux lines is going to be occur, so minimum voltage is going to be generated. So this is called the electromagnetic induction. So by doing that, by changing this number of turns, you could able to increase your voltage, or maybe you can able to decrease your voltage, right? So I think we are just going to stop it here, and we will continue by tomorrow classes. So with that in detail, right? So how we are just going to step up voltage, we are just going to step down current, and second side how we are just going to step down voltage and step up current. Anyway, power பாத்தீங்கன்னா ஒரே மாதிரி தான் travel ஆகும். So இந்த மாதிரி travel பண்ணா நமக்கு என்ன யூஸ் அப்படின்னா, copper conductor thickness we could able to decrease. So if you are just going to decrease your copper conductor thickness, you are just going to able to flow by increasing voltage and decreasing current, you would ultimately are just going to decreasing this area of that conductor. By doing this, you could able to reduce copper, that's called conductor manufacturing cost, right? So around 16 kilometer, imagine how much cost is required, right? So by introducing this type of technique, we could able to reduce entire that conductor manufacturing cost around 600 kilometer or 1000 kilometer, just imagine, right? So the maximum cost is going to be dropped. So this concept is now called transformer, T suffix F, transformer. Why it's called transformer? Electrical energy is now converted into magnetism. Again, magnetism is now converted into electricity. So this is called this big transformation is called transformer, right? So we'll continue by next classes, tomorrow classes will in detail, right? So I guess you hope enjoy it, right? I guess. So thank you all. Thank you for listening. So next class join பண்ணிக்கோங்க. We already crossed 3 o'clock. Thank you all. ஏ டவுட் இருந்ததுன்னா private எனக்கு சென்ட் பண்ணுங்க. EMCS குரூப்ல கேளுங்க. No, is nothing wrong in that, right? So thanks for listening.